Hello ma'am, I am Gamya Chirita from second year CSM A section. I am here to present my video assignment and my topic is classification metrics. Accuracy, precision recall, F1 score, AUC, ROC curve. Classification metrics. Understanding the key metrics to evaluate classification models in machine learning. Introduction. Evaluation metrics. Evaluation metrics are quantitative measures used to assess the performance of a statistical or machine learning model. These metrics provide insights into how well the model is performing and helping in comparing different models or algorithms. Here, the evaluation metrics under the classification. Here are the evaluation metrics under regression. In this presentation, I am going to present you about accuracy, precision, recall, F score, AUC, ROC curve. On moving to the next slide. Classification metrics. The definition of classification metrics is classification metrics are the performance measures used to evaluate the effectiveness of a classification model in machine learning. Importance of classification metrics are it helps to evaluate the performance of machine learning models. It also provides the insights beyond the simple accuracy. It is essential for real world decision making. Examples healthcare, fraud detection, etc. On moving to the next slide. These are the evaluation metrics for classification. Accuracy, precision and recall, F1 score, receiver operating system, that is ROC curve, area under precision recall curve, that is AUC, and confusion matrix. And next is specificity or true negative rate, etc. Understanding the confusion matrix. The definition of confusion matrix is a confusion matrix is a table used to evaluate the performance of a classification model by comparing its actual versus predicted values. Key takeaways are true positive means correctly identified positives, false positive means incorrectly identified positive rates, false negative means missed actual positives, true negative means correctly identified negatives. Key classification metrics. First one is accuracy. The proportion of correctly predicted instances among all instances is called accuracy, and the formula for accuracy is TP plus TN by TP plus TN plus FP plus FN. This means true positive plus true negative by true positive plus true negative plus false positive plus false negative. And the precision, and the next one is precision. The definition of precision is the proportion of correctly predicted positive instances among all predicted positives is called precision. The formula is here. Precision is equals to the ratio between true positive and the sum of true positive and false positive, that is TP plus TP by TP plus FP. And the third one is recall. The definition for recall is it measures how many actual positives were correctly predicted. The formula for recall is true positive by true positive plus false negative. And the next one is F1 score. Definition of F1 score is the harmonic mean of precision and recall. That is F1 is equals to F1 plus F1 equals to 2 into precision into recall by precision plus recall. And the fifth one is ROC and AUC, area under curve. ROC curve, it plots the It plots the recall true positive rate versus false positive rate at the different values. AUC ROC curve measures the area under the ROC curve, higher equals to better. When to use which metrics? Here we are about to get an idea to use the metrics based on the situation. Here are the metrics and the best use case. For accuracy metric, the best use case is balanced dataset. For balanced dataset, we use accuracy metric, and for high cost false positives means email spam detection, etc. For this, we use precision. And the next case, the use case for recall is high cost false negatives, means cancer detection. Means here we want to detect the we are expecting the negative rate, means cancer detection is should be negative. We are expecting the negative result. F1 score. F1 score is used in imbalanced datasets case. For overall model comparison, we use AUC and ROC. On moving to the next slide. Here is an example. Suppose if we build a model to classify whether an email is spam or not, here we get an idea by noting the spam mail as 1 and denoting the non-spam mail as 0. We test the model on 10 mails and we get the following result. For among the we have tested the model for 10 emails, we and the obtained results are given aside. On moving to the next slide. The confusion matrix for the from the table is true positive rates are 4 and the false negative rates are 1 for the actual spam. For actual not spam, false positive rate is 1 and true negative rate is 4. Classification matrix calculation. Here we find the classification matrix for the following for the given data. And the first one is accuracy. We know the accuracy formula, that is the ratio between true positive the ratio between sum of the true positive and true negative by true positive, true negative, false negative. That is the true positive value is 4 and the true negative value is 4. We know that the false positive rate is 1 and the false negative rate is also 1. So the overall calculation we get 8 by 10, that is 0.8. That means 80% of the mails are spam. Precision spam detection accuracy. For spam detection accuracy, the precision is we get the formula is true positive by true positive plus false negative. This means 4 plus 4, 4 by 4 plus 1, that is 4 by 5, that means 80%. Recall for sensitivity, true positive rate. The formula for this is true positive by true positive plus false negative. This is similar to precision, but in place of false negative, in recall we take false positive. Sorry, in precision we take true false positive, but here we take false negative. Here also the same value, that is 80%. The total rates are for F1 score. F1 is equals to 2 into precision into recall by precision plus recall. The F1 score would be 80%. AUC ROC curve. In this, the true positive rate is 0.9 and the false positive rate is 0.2. That is calculated from the true positive rate and false positive rate formulas. Conclusion. I finally conclude that the choosing right metric depends on the problem at hand. Based on the problem, we choose the metrics. Accuracy is simple but misleading for imbalanced datasets. If the datasets are not balanced, then the accuracy will be misleading. Then the solution obtained by the accuracy will be misleading. Precision and recall will help in cases where false positive or false negative have significant consequences. And the F1 score balances both precision and recall, while the AUC and ROC provide a comprehensive view of model performance across different thresholds. Thank you for giving this opportunity.